Hello everyone. Right, so without wasting our time, let's go with the first problem in today's fact set online assessment. Right, so the first question goes like this. Let me write the description clearly for you. Given an integer array, integer array, right? We calculate in this integer array. So we calculate the sum as sum of an element as, right, if I take this as array, if it is named as array, so array of I plus array of I plus k plus array of I plus 2k and so on. So I have forgot to mention that given an integer array and an integer k, right? So we need to calculate the sum of, sum at index I. It would be better if I wrote it, but in the OA round, it wasn't as clear as this, which I wrote here, of an index I as this one, right? And so on. So it wasn't as clear as this. So it was like jumping from one day to the next kth day, something like that. So it wasn't as clear as this. Given an integer array and an integer k, so we need to calculate the maximum sum, right? So we calculate the sum of an index I as array of I plus array of I plus k and so on, right? Now return the maximum sum. Return the maximum sum, right? So let us take an example. So 1, 3, 5 minus 2, 4, 8, 12, 15. And let me take k as 3, right? So for indices, let me give indices here. So if I give indices 0, 1, 2, 3, 4, 5, 6, 7, right? So this is an array of size 8. So if I take this element at an index 0, for this the sum will be 0 plus 3 will be here, plus 3 will be here, 3 plus 3 will be 6, and after that it will be going out of bounds, right? So let's stop there itself. Now if I go from here, I would go to 4 and then to 15, right? So this is just like a strings, right, from here to here, plus k, right? So I'll be going with the brute force one first and then the optimized one. Now if you see, from 5 plus 3, 2 plus 3 will be 5, and then it will be going out of bounds, so let us not go there. Now at index 0, I went to index 3 and then to index 6. I wanted to go to 9 also, but it is going out of bounds, so I stopped there itself. This is the case for index 0. Index 0. Now imagine if I started at 1. So we calculate the sum of an index I as array of I plus array of I plus k and so on. So we can also start at this point, right? So that can also be an answer. Now let us take index 1. If I started from index 1, I would go from 1 to 1 to 4 and then 4 to 7, right? If I started with index 2, then I would go from 2 to 5, 2 to 5 and from 5 to 8, but 8 is nothing but out of bounds. If I started from index 3, then I would go from 3 to 6. Now if I started with index 4, I would go from 4 to 7, and if I started from index 5, I would not go anywhere, 5 there itself. And here index 6, I would go nothing but 6. Index 7, I would go nothing but 7. Now what are the sum values here? So 0 to 3 to 6. From here to here to here. So 12 minus 2 is 10 plus 1 is 11, right? So here I am getting the sum as 11 if I started at index 0. If I started at index 1, 3 plus 3, sorry, 1 plus 3 is 4, right? 3 plus 8 is 11. Now after that, if I go out of ones, no need, right? 8 plus 3 is 11. So here also I got 11. If I started at index 2 here, from 2 I can go to 5, right? So 5 plus 8 is from here to here. 5 plus 8 is 13. Now if I started at index 3, I would go from here to here. 12 minus 2 is 10. Now if I started at index 4, I would go from here to here. 4 plus, no, wait a second, I think we have skipped something, right? If I started at index 1, 3 plus 4, 7 plus 15 is 22, right? 3 plus 4 is 7 plus 15 is 22. Yes. Now 5 plus 8 is 13. Okay. Now 12 minus 2 plus 12 will be 10, right? So from index 3 we can go, yes, 10. Now from index 2 I can go to 13, right? That's the sum. Now from index 4 I can go to 19, to the sum of 19. From index 4 I can go to 7, and the sum will be index the number at index 4 and index 7. 4 plus 15 will be 19. Now let us go with index 5 where I have 8. So here it is 8. At index 6 the sum is 12 itself. Now index 7, 15. So from all of these the answer will be 22, which will be starting at index 1, right? So here then 8 plus 3, no, 3 plus 4, right? 3 plus 4 is 7 plus 15 is 22, right? So that's how you solve this problem. Now if I have to write a brute force problem approach for this, so I'll be going from I is equal to 0 to n, and j will be starting with I, and it will not go beyond n, and j will be incremented with k. Now if you see every time, so right from 4 I can go to 15. Okay, so I can get the current sum every time, right? So here current sum will be 0, and here current sum plus is equal to, let us take array of j, right? So that's how you get the current sum. It will go to the end, right? Until it goes out of bounds, it will get the sum, right? So current sum plus is equal to array of j, and the answer will be int minimum, right? And answer will be updated. Answer is equal to max of answer comma current sum, right? So at the last we'll be returning the answer. So this is just a brute force approach. But if you see 135 minus 2, 135 minus 2, 4, 8, 12, 15. 4, 8, 12, 15. If I go in reverse, right, so Previously I went from starting to the end, right? From 1 to 2, minus 2, and then to 12, from 3 to 4 and 15. Now from 5 to 8. So that's how I went. But let's not go like that. Let us see. Here, if you see, I have 15. From 15 minus k, nothing but if I take the indices, I am talking about the indices 0, 1, 2, 3, 4, 5, 6, 7. 7 minus 3 will give you 7 minus 3 will give you 4. Now 4 minus 3 will give you 1, right? Okay. Now 6 minus 3 will give you 3. 3 minus 3 will give you 0. Okay. Now 5 minus 3 will give you 2. 2 minus 3 is, is less than 0. 2 minus 3 will be minus 1. Okay. Now, by using this, so if you see at index 7, what will be the sum? The sum I can get. The sum I can get is just 15. I cannot go out of that, right? Now, here 15 itself. Okay. Now, at this, do I have anything on the right? No, I doesn't have anything at plus k. 6 plus k is nothing but 9, but I don't have. No, it is 12. Now 5 plus 3 is nothing but 5 plus k is nothing but 8, but it is out of bounds. So here it will be 8 itself. Now 4 plus 3 will be 7. And what is the sum at 7? It is 15. So 15 plus 4 is 19. At this index 3 plus 3 is 6. 12 minus 2 is 10. Now 2 plus 3 is 5. At that I have 8. So 8 plus 5 is 13. Now 1 plus 3 is 4. Now 19 plus 3 will be 22. Now 0 plus 3 is, 3. Now 10 plus 1 will be 11. That's what we got here. 11, wait a second. 11, 22, 13, 10, 19, 8, 12, and then 15. What I just did here. So went from back to front, right from end to the start. Now, if I plus k, is less than n, then sum of I is equal to nothing but what I have at that element, that index, the element at that index, array of I plus sum of I plus k, right? Now I'll be updating the answer every time. So answer is equal to maximum of answer comma sum of I, right? So I need to check whether I plus k is less than n, right? So went from back to front and so on. That's how you go for this. Answer is equal to minimum int minimum, and at the last return the answer, right? This is the optimized one, but let us go to the brute force and let us see what is the time and space complexity there. So here the time complexity will be, for this loop it will be taking big O of n into big O of n will be big O of n square. What will be the space complexity? We are not using any additional space, so big O of 1 itself. Now let's go with the optimized one. What will be the, you know what do you say, uh, time complexity? We are just iterating through the array for just one time, so the time complexity will be big O of n, and the space complexity is, if you see, I am taking sum of I is nothing but the array. So n is equal to size of nums, right? And we'll be initializing vector of int sum with size n comma 0. So the space complexity will be creating a new array named sum. So big of n. Now let us go with the third problem. So there is a second problem, but if you see, I wasn't clear about the second problem, and I also have to check the link of any similar problem like that in code forces and also in coaches, so that I can come up with that. But for now, I'll be going with the third problem now. So let's see what does the third problem was. So the third problem was about, so we are given with a string s is equal to something like, uh, they gave me something like, you know fact set something like that. Now they also gave me values where for A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So everything will be having some values: 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 1, 0, 0, 1, 1, 1, something like that. So randomly they will be giving you this. So we need to know, right? We need to know, get the count of substrings, get the count of substrings, which, so we are going with a string s and an integer k, and so get the count of substrings which are having at most k characters which are zeros. So we need to just calculate something like count of substrings, with at most k zeros. That's it. That's what we have to do, right? So okay, so we are going with a string fact set like this. So what is the value of this string if I convert it into binary? So f is having 1, a is having 0, c is having 1, t is having 1, and s is having 1, and E is also having 1, and again t is also having 1. So let's see that, imagine we are given with k is equal to 1. Just take an example where k is equal to 1. So we need at most k zeros. They said at most k zeros. That means zeros, number of zeros can be less than or equal to k. Now we'll be going with a two-pointer approach, right? Two-pointer approach, nothing but a sliding window, but increment the right pointer. We'll be incrementing the right pointer every time, but shrink the window, or just increment the left pointer. Excuse me. Shrink the window. Shrink the window if number of zeros are greater than k. So if they are greater than k, then we'll just shrink the window. So we'll be starting with zeros. Number of zeros are 0, and answer is also equal to 0. Now what about n? N is equal to s dot size. We'll just change the s to the value which we are given with. So we have n, answer and then zeros. So let us see what else we required. L is equal to 0. Left and right pointers are initialized to 0. So for int, so let us just take this as here. Instead of here, let's be make it here. R is less than n and r plus plus. Now if you see, I will be shrinking the window here. Shrink window, shrink window if zeros is greater than k, right? But after shrinking the window, we'll be having the string or the two pointers which will be having the valid substring. So answer plus is equal to r minus l plus 1. So all the substrings in that, or the number of substrings, the size of the substring will be incremented, will be added to the answer, right? So if s of r is equal to 0, then just increment the number of zeros. Now while the number of zeros are greater than k, let us see what happens here. If s of n is equal to 0, then zeros will be decremented and we will increment the L pointer afterwards, right? So this is how you write the code for the number of count the number of substrings with at most k zeros. They asked for at most k zeros, right? So that's how you solve this problem. And if you have any doubts, please let me know in the live chat, right? So yes, we'll be ending this session. This is the smallest session. So I'll be sharing you with this link, right? Let me share you this link. Find maximum sum taking every kth element, right? So this is the first problem which was given. Yes. If you have any doubts, please let me know. We'll be ending this session at 9 p.m. exactly. Bro, you just commented that today you solved only second problem and third only two cases, test cases passed. I'm unable to solve sliding into third problem. Bro, we might, so there might be here. I also gone through a mistake for this one, right? When I am writing to shrink the window, right? I also confuse when I write the sliding window uh, algorithm, right? So yeah, I also confused solving the third problem. But let me know what is your approach for the second problem. I wasn't clear with the question also and also with the approach. So that's why I didn't explain today. I might share this in LinkedIn with everyone, right? So let me know that what was your approach for the second problem. The first problem was something like a prefix sum and something like this pattern is done like house robber problem, right? In dynamic programming, house robber problem, which was a quite similar problem to the first one. So given an integer array and an integer k, we calculate the sum of an index I as array of I plus array of I plus k plus array of I plus 2k and so on. We just return the maximum sum. So if you have any doubts, please let me know. We'll be ending this session in just 6 minutes sharp at 9 p.m. Right? So this, okay.